In this video, we're going to look at an introduction to rational exponents. Now, a rational exponent is just a fractional exponent. Okay, so it's any rational number or fractional number, a number that can be written as a fraction. Now, before we jump into this notation, I want to show some examples of where rational exponents, where this stuff is coming from. So here I have a squared written down twice. One of the a squareds, what I'm going to do is I'm going to take the square root of a squared, and in the other a squared, I'm going to raise the a squared to the 1/2 power. Okay, so in one of the examples, I'm going to take the square root of it. In the other example, I'm going to raise it to this rational exponent, this fractional exponent. Okay, this is a rational exponent. Now, when I take the square root of a squared, remember that square roots are really asking you what number times itself equals the expression underneath the radical. So what times what gives me a squared? Well, a times a gives me a squared. So the square root of a squared would simply just be a, because when I take a times itself, I get a squared. When I look at the second expression that I've raised to the 1/2 power, when I raise a power to a power, I multiply the exponents. Well, if I take 2 times a half, well, I just ask myself, what is half of 2? Well, half of 2 is 1, so I get a to the first, or just a. Notice that when I take the square root of this, or when I raise it to the 1/2 power, both instances, I get a for an answer. What this means is it means that taking the square root of any expression under here, okay, anything I put underneath, is equal to taking whatever I had to the 1/2 power. Raising something to the 1/2 power is the same exact thing as taking a square root. Okay, they mean exactly the same thing. They're the same way of rewriting the same thing. Let's look at another example that's similar to this. Let's say I start with two expressions. Here I have a to the third, and here I have a to the third. This a to the third I'm going to raise to the 1/3 power. This second a to the third I'm going to take the cube root of. Okay, so if we start with the one on the left, when I raise it to the 1/3 power, remember I'm multiplying the exponents. Well, 3 times 1/3, well, that gives me 3/3, and 3/3, 3 divided by 3 is 1, so I get a to the first, or just a. Okay, so when I take a to the third and I raise it to the 1/3, it simplifies to be a. When I take the third root of a to the third, okay, I'm asking myself what number or what thing or what letter variable when raised to the third power will give me a to the third. Well, it's got to be a. The question mark equals a, right? A to the third equals a to the third. So this expression will be a as well. Now notice this time I started with the same expressions, and when I raised one of them to the 1/3 power, I got an equal expression to when I took the expression and took the third root of it. So raising something to the 1/3 power is the same thing as taking the third root of whatever you have. Now, notice, in the first example, we saw that square roots were the same as raising something to the 1/2 power. In the second example, we saw that third roots, or cube roots, are the same thing as taking things to the 1/3 power. This pattern goes on forever. So what I mean by that is if I want to take the fourth root of a number, or of anything, that's going to be equal to taking anything to the 1/4 power. These expressions are identical. Taking something to the fourth power is the same thing as taking something to the 1/4 power, or 1/4 power is the same thing as taking the fourth root of the expression. Similarly, if I took the fifth root of an expression, that's going to be the same thing as taking it to the 1/5 power. This bottom number is the same thing as the root. So that's the first thing I want to discuss in this expression. Now here I kind of wrote it sloppy, so I'm going to rewrite it. If I have a base and I take it 1 over any number, okay, call that number r. This expression will be equal to taking that base to that root. Okay, so if I have b to the 1 over r, that'll be equal to the same root of the base. So for example, if I had a base and I had it to the 1/6 power, that is the same thing as taking the 6th root of that base. Okay, 1/6 power is the same thing as this. Now, the reason why I denoted this with an R is because this is the root that I'm taking. This bottom number is equivalent to it, so this you need to remember is your root of the expression.